Projectiles are a tricky subject, and in fact, let's cover what a projectile is. A projectile is simply anything that's moving in two directions. And so if I shoot a basketball, or I kick a soccer ball, or I shoot a cannonball, or launch anything pretty much at an angle like this, let's say this represents my velocity, then it's really moving in two directions. One direction is in the x direction, obviously, and it's also moving, in this case, it's moving up. Right, and so these are the components, as we covered in a different video, of velocity. And those components actually signify that it's moving in two directions. Now let's go and actually extend this arc a little bit. So let's actually draw that arc. And so let's say that projectile, or whatever it happens to be, is moving in this arc. And by the way, this could also be, like maybe a bullet being fired horizontally. So if something's fired horizontally, it might appear that it's moving in a straight line, but in reality it actually is ever so slightly dipping down, right? And why is that? Why is it moving down? Well, it's because of gravity, right? Gravity is pulling that object down very slowly, like a bullet. And so let's go ahead and focus on the top example here, and let's actually break this down into a chart. That's the best way to visualize this and understand all the things that is going on with this projectile. And let's go ahead and draw that chart here. So this is going to be my X and Y chart. And again, the reason I'm breaking down into X and Y is because these are my two different directions, two-dimensional motion. So let's go and start off with the most obvious thing on this projectile, the velocity. The velocity in this case is going to be v naught x. Okay, v naught represents your initial speed, and the x subscript here represents the fact that we're referring to the x direction. And in order to actually find that component, this is like the label for the component, but if I actually wanted to find like a numerical value, how would I do that? Well, assuming that I have an angle here, what I can do is I can take that angle and use the sine function or the cosine function, depending on which side it is. In this case, it's the adjacent side to the angle, and so I'm going to use cosine, and I'm simply going to do v naught cosine of theta. And so again, if I wanted to find the actual length of this vector, I would just plug in all the numbers. I'd plug in v naught, my initial velocity, I would plug in theta, and I'll end up with a number. And so let's go ahead and fill that into the chart right here. So this would be v naught cosine of theta. All right, and how about the velocity in the y direction? What's that going to be? Well, that's going to be v naught y. So we're going to label that v naught y, and again, that means initial velocity in the y direction. And that initial velocity in the y direction is going to be v naught sine of theta. Okay, so again, if you want to find the actual magnitude of it, we're going to say v naught sine of theta, because again, this side that we're trying to find is opposite to the angle. So we're going to write v naught sine of theta. Again, if you're confused as to how I broke these down into vector components, I'd recommend watching the video on vector components. It would make a lot more sense. All right, now moving on to the next kinematic variable. Let's do final velocity, actually. So v final in the x direction, and v final in the y direction. Let's start off with this one. This is the easiest one. V final in the x direction is actually going to be the same as the initial in the x direction. And the reason for that is because the initial velocity in the x direction never changes. It literally never changes. So if it started off, let's just give this a number. Let's call this 5 meters per second. That x velocity, or the velocity in the x direction, will always be 5 meters per second throughout the whole arc, 5 meters per second, even at the very top. And so a common misconception is that the speed decreases to 0 at the very top. That's not true. The speed in the y direction is decreasing to 0, but not in the x direction. In the x direction, let's fill this out really quickly, v naught cosine of theta, these two are going to be the same. And this is what I like to call a redundant variable. And so generally when we problem solve, we don't even really use that. And as for v final in the y direction, this one just depends on where exactly you are looking at the arc. And so if you're looking maybe down here, then this velocity in the y direction is going to be the same as the initial velocity in the y direction, right? It's going to come back down to the same exact speed, just in the opposite direction. However, if you're looking right here, it might be different. If you're looking at the very top, it's going to be 0, right? Because it's gonna, gravity will slowly slow it down to 0 in the y direction, just to be clear about that. All right, and for the next kinematic variable, let's cover acceleration. In the x direction, it turns out that acceleration is in fact 0. Why is it 0? Because again, acceleration means a change in speed. And if the speed does not change from the initial to the final, right, there's no change in speed, then the acceleration is effectively 0. In the y direction, however, there is a change in speed, right? It's slowing down as it goes up, and then it's going to speed back up as it comes back down. And so in the y direction, the acceleration is really due to gravity. So it's going to be 9.81 meters per second squared. And again, this applies to all projectiles. Gravity will always pull it down in the y direction. And to really quickly just highlight a common misconception, a lot of people get confused about if this should be negative or if this should be positive. The truth is either one will work depending on the context and the direction that you've initially set up. So for example, let's go ahead and set up a coordinate system right here, and let's just say that up is positive in this case, and let's say down is negative. So if I was to set my coordinate system up like this, and gravity, as we know, it always points down, then gravity will be pointing down in the negative y direction. And so then I would give my value for gravity a negative sign, just like that. And then just to quickly cover the last two variables, these ones are typically the easier ones. It's going to be time and displacement. And so time is going to be the same on both sides. And this one's interesting because they're the same on both sides, we can actually find it on one side and then use it on the other side as well. And so this is like the bridge between the two sides here. Okay, and the last variable is displacement. This one is relatively easy to understand. And displacement in the x direction is what we call our range. It's how far we traveled. So I'm going to go and write that down here. It's called range. And displacement in the y direction is, in other words, our height, right? It's our height, it's how far we travel. Now, there is a little bit of a misconception here. When I say height, I don't really mean the maximum height. It can really mean any height. So it can mean maybe if I'm analyzing at this point, it can mean the height from here to here. It can maybe mean the maximum height from here to here, or it can maybe mean the height from here to here. So really at any given point. It can also mean the height at the very end. Well, what's the height at the very end? Well, the displacement, if it starts here and it ends here, the displacement in the y direction is actually 0. And so if you're analyzing the whole projectile motion, then the displacement vertically, the height, in other words, is going to be 0. All right, so that wraps it up for understanding the kinematic variables in projectile motion. And in the next video, you're going to see that we're going to take the exact same method and apply it to pretty much any problem that we want to solve a projectile motion problem and actually get a numerical value. All right, that's it for this lesson. I'll see you in the next video.